Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is lesson 8-7 for course 2, the Pythagorean Theorem. Here we're going to use the Pythagorean Theorem to solve real-world problems. Basically those are problems centered around right triangles, as the Pythagorean Theorem applies to right triangles. Okay, so first of all let's look a little bit at that theorem. It says, the Pythagorean Theorem states that in any right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Okay, now that's an interesting word there, hypotenuse, isn't it? Okay, so basically that gives us, and this is something again that you will see throughout your math career, a squared plus b squared equals c squared, okay? Where a and b are the two shorter sides of the right triangle, they are also the two sides that make the right angle, by the way, is equal to the square of the hypotenuse. The hypotenuse is the longest side of the right triangle, and it's opposite the right angle. And basically, that's what we're going to write right here in our definitions. So, in a right triangle, the legs are the two shortest sides. Again, it's good to know that they will form the right angle. The hypotenuse is the side opposite the right angle. Okay, I'm abbreviating right angle in case you didn't get that. Generally, too, it's going to be, not generally, it is the longest side of that right triangle. Okay, so if we look at our schematic, or a little sketch over here, here's the right angle. So that makes these two sides the legs. So leg, leg. And it doesn't matter which one is A and which one is B. And the hypotenuse is the longer of the three sides. It's also the longest word. It's also a unique word, so you'll probably remember that. All right, so let's look at finding the length of a hypotenuse. Find the length of the hypotenuse of the triangle. So again, the formula is c squared, so they just brought that to the front. C squared equals a squared plus b squared. Doesn't matter that the c squared moved to the front. It's just commuted to the front, not a big deal. Okay, so when I look here, my legs are 7.5 and 10. So this is going to be, a squared is going to be 7.5, and I'm going to square it. So this is A and this is B, if you want to see how that works into that. Okay, so 7.5 squared should be 56.25. And 10 squared is 100. Add those together and you get 156.25 as the square of the hypotenuse. Now, when you want to know how, now you're trying to figure out, well, what number did we square? So you're going to have to take the square root of c. That's why that's there. And the square root of the hypotenuse. So again, 156.25, square root it, and you get 12.5. So the length of the hypotenuse is 12.5 centimeters. At the very least, to check if it's reasonable, it should be longer than either of the other two sides, and it is. And again, you could always substitute all three numbers back in to check. Okay? Finding the length of a leg. Okay, this is a similar process, but instead of the hypotenuse, we have one of the legs missing. Okay, so, and it looks like they've assigned the missing leg as A. So I'm going to fill in my sketch here to fit that out. Okay, so A squared plus B squared equals C squared. So A squared equals b squared, so 15 squared, a squared plus 15 squared equals 25 squared. 15 squared is 225, so I end up with a squared plus 225 equals 625, just by simplifying. Then I'm going to subtract, using algebra, 225 from each side. And I get a squared equals 400. So I'm going to take the square root of a squared and the square root of 400. The square root of a squared is a, the square root of 400 is 20. So the length of the leg is 20 feet. Again, that seems reasonable because it's shorter than the hypotenuse, and you know, at least that much you can check to see if it's somewhat reasonable. Again, you can always double check by going through and filling in all three numbers and being sure that they give you the right answer. Okay. A ladder placed 4 feet from a wall touches a wall 11.3 feet above the ground. What is the approximate length of the ladder? A sketch shows that the length of the ladder is the length of the hypotenuse. So you have your sketch over here. Here's the wall. It touches at 11.3 feet. It's 4 feet from the bottom of the wall. Okay? So c squared is equal to, let's see, a squared plus b squared. Okay, so let's take a to be 4 and b to be 11.3, just so it fits in the boxes the way they have it presented. It really doesn't matter which one is a and which one is b. Okay, so 4 squared is 16, and then 11.3 squared, is 127.69 plus 16 gives us a total of 143.69. So the square root of c squared is equal to the square root of 143.69. When you square root that, you get 11.987, and it continues. We can round this to the nearest foot if we want to. That's so close. Well, even if we rounded it to the nearest tenth, it would still come out to 12 feet or 12.0 feet. So 12 feet is a good answer here. And if this is pretty short, the hypotenuse isn't, if one of the legs is pretty short, the hypotenuse is going to be closer to the length of that longer leg if there's a larger discrepancy between them. Just kind of an FYI to see if it's reasonable. Okay, you have 3 quick checks to have done. Number 3, I would probably recommend, I would recommend drawing a sketch to help you get a better feel for what you need to be doing. Okay, bring in any questions or concerns. See you soon. Bye now.